Hello and welcome to another video for my vintage electronics channel, and this time we'll be looking at another radio. It's a Vidor CN430, or commonly known as a Lady Anne radio from the mid-1950s. Let's see how I get on. So here is the Lady Anne radio by Vidor, or Vidor, not sure how to pronounce that. Vidor sounds pretty good. They're a battery company really from the 1950s in the UK. It's got their origins in 1920s, but they did go on to build radios like Eveready did. They competed with Eveready. It makes sense really because that drives demand for their batteries. This one is a battery mains one, which is what attracted me to it. It's a nice size for my collection. I can move this, doesn't take up much space, and I can move it around the house. And I can use it with a close coupled antenna or coil to induce some signals in there, so I can use it. I quite like it, and it's a really nice condition case. These were made from 1955 onwards. Got a luxurious feel with this sort of velvet. Maybe the colour scheme's not to everybody's taste, but I quite like it. It's in great condition, so I'm not really going to do anything with the case. So a lot of people don't like these battery radios. I like them because I think they sound good. Some people don't like the sound. Obviously, they're very simple circuit. The ones I've had have had excellent sound, lots of power, lots of dynamic range. I really like them. Some people don't like them because the batteries are awkward to get. In fact, impossible to get. You have to improvise stuff. But this has got its own mains, so I think it's great. And it cost £10 as well. I got a feeling the guy was going to throw it away. I thought that'd be a real shame. It's to me, it's worth a lot more than £10. But there's not a lot of demand for long wave, medium wave radios, and there's not a lot of demand for valve radios. Like everything, it's got a service sheet, and that gives me a good idea of what to change. And I'll review the circuit now. So reviewing the circuit. So the antenna is built into the lid. And there are two antennas in there, one for long wave, one for medium wave, and they are tuned with C30, which is the tuning capacitor. And the first valve, V1, is the oscillator, and that induces the intermediate frequency. I think it's got an IF of, I think it's 450 hertz or kilohertz. I'll double check that, doesn't really matter at this point. And what happens then, V2 provides some IF amplification. That in turn is then passed to V3, which has a diode detector stage in, and also the first amplifier stage, which is amplified using a pentode section in the V3. And then the output valve, V4, gives it the final boost before being passed to the for the AF is being passed to the speaker. A thing I did note is that there is what they call a metal rectifier in place here. It is I'm guessing it's a selenium rectifier. Now they do degrade over time, so I'm a bit wary about using that, so I will change that. I might do some tests on it first, but probably not a good idea to keep it. The challenge is there will be a voltage drop across that rectifier, and it can be quite high. We do have a clue. There's obviously no voltages on the schematic, but the text does say that across C28, which is the main filter capacitor, there is a 110 volts DC. Yet across the anodes of the rectifier, which is across the secondary of the coil, it's 110 volts, sorry, 100 volts AC. So that must be RMS. So if you put that to a peak, then that's about 141 volts. So that gives us a rough idea what the voltage drop is across the rectifier. So that's about 31, 32 volts. So these need to be verified. So what is the resistor I need there to drop that? Conveniently, it does say that the current draw along from the radio from that rectifier is 9.8 milliamps, so about 10 milliamps. So that gives us a good idea that we probably need to be putting a 3-watt resistor in there as a minimum, probably a 5-watt resistor. And let's assume that resistor is about 300 ohms. That should give us the approximate voltage drop needed, but we'll verify that later on. So that's it. I've got to think about how to go about repairing this, making sure it's safe. I'll give it a good inspection now and see what we need to do. Okay, so let's have a look inside. I've taken just these basic bolts out, or not the air bolts, so that's all freed up. And let's have a look. So just looking at this, initially, it's very clean inside, really pleased. All the battery connectors there. All the valves are here, all very clean. I'm not surprised it's clean because it's encased in this, close to the elements really. So what we've got to change, well, this will be the rectifier here. It's a big beast. I'm pretty sure that's a rectifier, so I'll just make sure that's what it is, or this could be it. I don't know. So I need to do some research there, that's for sure. And what else we've got? We've got some wax paper capacitors. That'll need to be changed. Some electrolytics. They'll need to be changed because I don't keep them in if I'm servicing radio. Obviously, to get to the main chassis, it's underneath here, so I will need to take the dials off the knobs and unscrew that to open it out. So yeah, everything else is in really good condition, so I'm really pleased. So yeah, it might be a little bit of a challenge, but I think once I get inside it, I think it'll be good. Like I say, I need to do some research on these rectifiers. I've not really seen many of them. So yeah, good challenge ahead. Probably not best practice, but I'm intrigued to see if this radio works. So I do have a dim bulb on there, and I do have a variac just to bring it up slowly. And I've got it set to the mains medium wave and the volume low. So I'm just going to bring it up slowly. So if there's any problem with shorts or overheating, then the dim bulb should take care of the consequences of that. Getting some buzz out there. It's up to 100 volts AC mains at the moment. And I don't know if you can hear that, up to 220 volts, and I'm getting a bit of life out of this. So I just put it up to 240. Let's see some tuning.
Narrative. We've talked about all sorts of things. We've talked about saunas. We talked about his family.
Well, that's working on medium wave.
About how he survives in between fights and what his life's like, because we know so much about him, but we know
Talk sport. So that's good. It's working. There's nothing at all on the dim bulb. What concerns me is this volume and control is down to its minimum. We're still getting quite a bit of sound through there, so there's definitely a problem.
Did you come away from this one thinking it had gone quite well, or how did you?
It's definitely got a lot of power. I was barely touching that volume control. So that's an interesting conundrum now, really. It basically works. I suspect there's still quite a lot of leaking capacitors, and I've got this volume control to sort out.
He put his arm, because him and I have got the sauna thing up.
But actually, the reception's very good, and there's normally a lot more noise in my environment. It seems to be picking it up, so I'm very impressed. Okay, so it's time to start disassembling the radio. With the selenium rectifier, I'm going to keep that for the moment. When you do research and look at these things, the manufacturers claim a lifespan of about 60,000 hours. That compares to about 4,000 hours for a valve rectifier tube. And they do deteriorate with storage in moisture. But looking at this radio, it almost looks new inside. All the valves look perfectly new. There's no real sign of it being used extensively, and there's no corrosion. So my thoughts are, if I can get away with leaving the selenium rectifier in place, I will do. My plan is to test the B plus voltage, and if it's around 100 volts, then I think the rectifier is good, and we'll leave it in place. As they do age, the resistance of those devices increases. That increases the power loss, and they get hotter and drops the voltage. So that's just something to be aware of. I'll just check out the voltage. It should be around 100 volts. What I need to do now, though, is get these knobs off. Now, looking at the service manual, this central dial-in knob is attached with a grub screw. And actually, when you lift this up, there's a little plate you can move, and you can access that grub screw. That makes my life a lot easier. These two have to be pulled off. So my idea is to tip a gain sim from the internet and test it out. I'm just going to put a little bit of heat onto these knobs. This has been regulated to about 60 degrees, so it's just going to warm them up a little bit. And the selector switch here and the volume do need to slide off. So that's going to be the next job. Just start to get these warmed up. Right, I'm just going to see if I can take this off by hand, first of all. Probably not the best way. It's coming off really quite easily. And that's a real relief. No damage there at all. So I'm just going to do the same technique to the other one. Okay, that's the volume knob off. Took a little bit more work, but it wasn't too bad. There's no damage to that at all, so that's a good relief. I do need to get the dial-in tuner off, the tuning knob, and all I need to do is take this plate off, and I can get a screwdriver in there to access the grub screw. So hopefully that's going to be straightforward. Yeah, and there we are with that. It's just a little grub screw there, and that came off very easily. So I'm in a good place now to actually carry on with the disassembly. Right, there's the first look at the chassis disassembled. It's quite cramped in terms of components. I'll probably put some extended cables on to the speaker so I can get rid of this plate and get it out of the way. I'll still test the radio. I don't want to disassemble it anymore because it means I can test as I go along and test the B voltages. Looking here, we've got 1, 2, 3, 4 wax paper capacitors. I want to change those, and on the top side, let's just see that there. We've got 1, 2, 3 electrolytics and 1 wax paper capacitor. So I'm going to go through this properly now and just work out what I need to change. Okay, so time to change this reservoir capacitor. I haven't tested it yet, but I will test it. I'm pretty sure it's going to be leaky. I do test all components before I actually do any desoldering, but I am anticipating that it will need to be changed. And I would prefer to do that anyway, just because I don't want to go back into the radio, and I want to make sure that everybody uses the radio is not going to have any problems or incidents. So that's what I need to do. It's 232 microfarad capacitors in there. So these are the replacements, and you can see I could easily restuff that can, and I'll leave that option open to do that. I generally don't restuff things, really, because it's my radio and I don't really need the aesthetics. What I've decided to do is actually just 3D print this holder really just to drop the two in. There's a clamp on the side of that capacitor, and I want to reuse that. This little plug basically gives the option of just slotting the can over the top if I decide to empty the content. So I do have the option of returning that to the aesthetic visuals that it was before. And those are the capacitors just inserted in there, not just clamping nicely. They'll stay in place when they're soldered in. So that's what I'm probably going to put in place. Like I say, I want to test that capacitor first before making a final decision. But that's where I'm at this particular point. Right, that's the filter capacitors in. They're in there. They're wet in quite well. It is very tight. So it is, well, the chassis is very cramped. So that's what I expected, really. The main filter capacitor, June 1955, that was definitely shot. I did test that. Both sides very leaky indeed. So that really needed to be changed. So what I need to do now is just give it a test. I'll probably just put it on the dim bulb, actually. I don't think I need the variac. So we'll just see how we get on. What I'll do is I always change a capacitor, then test. I know it's laborious, but that's the easiest way to backtrack if you find you run into a problem.
Rolling and up and down, you still get a big sting in the legs. Whereas when it's a lot flatter now, as we have here, you've got flat running this one. Yeah.
There we are, working very well. So pleased with that. Still got that volume on the minimum. So we'll look at that. I want to check the B plus voltage now, really, just to make sure I'm getting about 100 volts. And that gives me an idea whether the rectifier is in good condition or not. Right, I'm really happy with that voltage. I've actually just taken off the dim bulb because that just dropped the voltage a little bit. So the documentation says it should be 110 volts with a 225 volt mains. I've got 240 volt mains. So if you do the maths, that should be around 117 volts. I've got 116.3, so I think that's very close. So I'm very, very happy that that rectifier is working as it should do. So I'm not going to change it. I'll just keep it as it is. Okay, so that's another one changed, this capacitor here. And again, it wasn't really good enough testing wise for me. I think some people might have let it go. It was fairly leaky. This one's actually dated September 1956. That puts the radio just a little bit later, which is always interesting to know. I don't think that was fitted afterwards. I think the radio is just a lot later than I thought it was. So all I need to do now is this final electrolytic on the top of the chassis, and there's an associated wax paper capacitor there as well. So I'll get those done now. Right, that's the last of the electrolytics changed, and it really was bad. That was 100 microfarads, extremely leaky, capacitance reading all over the place. I've also changed the first wax paper capacitor. That was in a really bad condition. I hardly registered any capacitance, and in fact it had a 300 kilo ohm resistance measurement. That should be virtually zero. So both of those were bad. Time to test the radio.
Who leads this race and is ahead of his teammate. If the orders are to follow, then he will get.
And that's working really well still. So I'll just check out the volume, see how we're getting on with that, see if it's made any changes. I'm not expecting the volume to go to zero because when I measured the potentiometer, it's got about a 1.1k minimum resistance on there. So that will count for some of the volume, but it was disproportionately loud when I was testing it before. So we'll see if that's made any difference. Well, that's the volume right down. I'm not sure if you're going to hear that microphone. It's actually a lot quieter on its minimum volume.
We are counting down now to kick off at the Women's European.
So we've still got quite a lot of volume going the other way. So definitely some progress there. I'm going to change all the capacitors out. It's just 4 wax paper capacitors changed now, and we'll see what effect that has on the overall volume of the unit. Right, that's the radio recapped. I'll just point out the ones I've changed. It's 1, 2, 3, 4. Very easy to do, actually. And it's sounding pretty good. I'm not going to change this potentiometer. I've decided the volume is low enough that I can just live with that, really. And there's a lot of effort to change it, and I'd rather keep the original in because it's a very clean pot as well with the volume. So just give it a turn up.
Not just for the tournament, but for probably a bit longer. And I remember just sitting there, what's wrong with it? I was like, I think I've got a fracture in it. And I was like, yeah, that's a pretty big deal. Like, that's not just like, it's not just like a passing comment that you make. But
so all I need to do now is change the mains lead. It's a little bit cruddy, and then just put it back together. So these are the capacitors that have changed. All these electrolytics were bad. This one was bad. The 100 microfarad one was terrible in terms of leakage. The 50 microfarad, this one here, was okay. Some people probably will let that go, but I really don't want to go back into the radio, but it might have reformed over time. Anyway, it's a ticking time bomb in my mind, so probably good to get rid of it. The wax paper capacitors were terrible, all of them. I'm not surprised because every radio I work on, these are always shot. I think this one here was reading about 300 kiloohms as a series resistance, so that is not good. I could just stick a multimeter on there and just test the resistance of it, which is crazy. So they've all been changed, and like I said, the last step now is just get the mains lead changed and put it back together. So just as I thought I got over the finishing line, I hadn't. And a couple of things occurred to me. One, I hadn't checked the resistors, and it's at least one that's out of specification. There are another couple I need to check, and I'll do that, make sure they're okay, but most of them I've checked are fine. Also, I've got a new mains lead on, and this will have an earth, really just to earth the front panel, because that's metal, and I just want that to be safe. I mean, it's very close to the live actually here, so there is a possibility it could go live, so I will do that. The main thing is actually there's a couple of little, well, there's 3 little capacitors here, which are definitely molded capacitors. I think they look like bumblebee capacitors. I thought the resistors initially didn't look close enough at the chassis, so that'll teach me. So what I'm going to do with those, I'm going to test them because they are running at a fairly low voltage, so they may not be that leaky. So I'm going to make sure they're okay, and if they're okay, we'll leave them in. They're actually decoupling the screen voltage for each of the valves, so that's what their function is. And yep, I'll just get on with testing the leakage current on those. Well, those 3 capacitors, they were molded capacitors, definitely needed changing. They're measuring between 5 picofarads and 10 nanofarads. And yeah, they weren't very leaky. They'll just go in towards open circuit, really, so not doing the job. They've been changed. Obviously, the radio's back together now. Just giving it a light clean with some warm soapy water. Nothing more than that. Quite a lot of yellowish substance came off, which I suspect is nicotine. So it's a little bit cleaner now. All I've really done is brighten up the logo there, because that's pretty much worn off, so that's kind of been replaced. So all I need to do is give it a final test now. So that's the Vidor CN430 Lady Anne radio done, and I really love the radio. It may be a little bit tinny for some people's ears, but I think it's great, and it's got a good solid sound, a good strong sound. It's a very good quality chassis, good quality components from what I could tell. So I think I'm going to get a lot of use out of it, and it's really nice and portable to carry around. So it'll be on to the next project. If you do like these videos, then please do subscribe. Really appreciate the support, and I'll catch you with the next project.